So 4.1 angles and angle measures. Standard position, the definition. Standard position is when we sketch angles called rotational angles on the Cartesian plane, the XY axis, with the initial arm where the angle starts at the positive x-axis. These angles can be positive if you move counterclockwise and negative if you move clockwise. That's review from 20-1. So here's your lovely Cartesian plane. Remember, if we're going positive, and we'll use degrees for now, this is 0. And we always go counterclockwise. This is 90. This is 180. This is 270. This is 360. So positive moves counterclockwise. So if I said 210, you would start with one arm on here, and it rotates around 0, 0. So here's my arm, starting at 0. And then I have to go to 210, which is how many more than 180? 30. And this cuts in half at 45, right? So it's about here. And then you have to draw the arrow around, or else who knows if it's this way, which is a negative angle, or this way, which is a positive angle. We agree? So this is a positive angle of 210. Now we're going to look at the exact same arms at negative angle. So we label it backwards. 0, negative 90, negative 180, negative 270, negative 360. We start on here. We rotate around 0, 0, and we're 30 less than this. We agree? But what angle are we at? This time we're 30 less than 180. We're not 30 over 180. So what would it be? We go from here to here. Negative 150. Our terminal arm, the arm where it terminates, is at the exact same spot, is it not? These are coterminal angles. Because their arm terminates at the exact same spot. If it terminates at the exact same spot, you have coterminal angles. So how can we prove that? Well, we have 210 degrees. If I subtract 360 from it, that should get me a coterminal angle. We agree? Because if I subtract 360, I'll get right back to where I started, because the circle's 360. So if I subtract 360 from it, it's going to cause me to go this way. So I'm going to get negative 150. So they are coterminal. I could take negative 150 and I could add 360 and it would get me to 210. Because if I rotate a whole circle, I'm back at that same terminal arm, right? Which is 360 degrees. The terminal arm is where the angle ends, and it can be in any quadrant or on any axis. And then what angles correspond to each of the axes, I already labeled them. So I want you guys to sketch these 4. And this needs a degree symbol. Remember, if there is no degree symbol, it's radians, right? So you need to have a degree symbol. So 40, 0, 90, 180, 270, 360. 40 is not exactly halfway, but we start with our initial arm. We have to draw that. Then we have our little dot. And then 40 is almost halfway. And then you put an arrow in here to say it's 40. If you don't put the arrow in there to say it's 40, it could be actually negative 320. Because we could have an arrow on the complete outside of that. Correct? We have to actually give that arrow. 140. Make sure you always label your axis. 140 is 40 less than 180. This is 140. I have to remember to draw my initial arm. Then I have negative, so 0, negative 90, negative 180, negative 270, negative 360. I start here. Negative 270 is 30 away from 270, right? So it's going to be here. Negative 240. And then 340. Starts here. I'm 20 away from 360. So 340 degrees. We agree? You have to draw the initial arm so they know where the heck you're starting. You can't just draw an arrow from the x-axis. Okay, radian measure. You guys have already went through this. So I remember it as Dr. Pot. Degrees to radians. Nope. Pi on top. And then RD Pob, some people like, or they just go, hey, it's the opposite. Up to you. RD Pob is radians to degrees. Pi on bottom. I criticized the other one, but now they seem to remember it, so I guess it works. So why not? So if you go degrees to radians, pi on top. If it's the other way, then pi is on the bottom. So you don't really have to remember RD Pob, but if you'd like to, please go for it. So you're either multiplying by pi over 180 or you're multiplying by 180 over pi. Which you guys did last year, yes? You converted to radians, did you not? Half of you are looking at me like, radians? What's a radian? Which scares me because I'm 100% sure you learned. Oh, Christine. So, convert from degrees to radians. Degrees to radians, pi on top. And it wants it in exact values. So exact values means not decimals. Okay? So we're going to go 270 degrees times, so degrees to radians, pi on top. So we multiply by pi over 180. So that's going to give us 270 pi. I really don't have room in here. Divided by 180. And when we reduce that, what is it? Close. 3 pi over 2. It's that. Okay. 315 times pi over 180. So you're going to get 315 pi over 180. And what does that reduce to? I think it's 7 pi over 4. Yeah? You'll have them memorized after a while, writing out the unit circle 8,000 times. Yeah. So then it says, convert the following from degrees to radians to the nearest tenth. Now this sounds ridiculous, like people should be able to do it, but this one I find people get more wrong than the exact values. So we multiply by pi over 180. So we're going to get 70 pi over 180. Then some people type in 7d divided by 180 and then write that decimal pi. Rookie. So you need to put this into your calculator divided by this. Now, because your calculator does bedmass rules, if you don't put the brackets for this particular instance, it'll work. So go 70 pi divided by 180. Nope. It would just be radians. To the nearest tenth, so it's going to be 1.2. So with radians, you can either put nothing, and then it's radians, or you can put rads, or you can put radians. So it's throwing him into it. Back into mine? No. No. So when you get 1.2, that's just radians because I didn't write anything behind it, but I wrote rads or radians. So that's why the degree symbol is extremely important, right? Because if you don't have it, then it is a radian measure. 205 times pi over 180 equals 205 pi over 180. And it's 3.6. I want you guys to see if you can remember to do this. So this one is what? Instead of multiplying by pi over 180, what are you going to multiply by? Bingo. So we're converting the following from radians to degrees. So we're going to multiply by 180 over pi. Because I have a pi on the top and a pi on the bottom. They cancel. And you get 45 degrees. And you have for the degrees or else not degrees. So we're going to multiply by 180 over pi. Pi's cancel, so when it actually has a pi, it's easier. And what do you get? Negative what? 420. Okay, convert the following from radians to degrees. Okay, so this one is going to be 1.57 times 180 over pi. So you literally have to do 1.57 times 180 over pi and then give me the decimal. Remember, if it wants it to the nearest tenth or hundredths or decimal, you have to input the pi into your calculator. So you get 90.0 actually, because it's 89.95, so it would round up to 90.0. And then this one times 180 over pi. Okay, shush. Negative 1.4 times 180 divided by pi equals negative 80.2 degrees. The next little bit of what we look at actually follows the very top formula on your trig formula sheet. Theta equals A over R. Okay? This is your arc length. This is your radius. So if you get degrees, you're going to have to divide by 2. The catch also is these have to be in the same units. Never really seen that be a problem, but they do have to be in the same units. Hello. And then this is the big deal. It's an angle, but it has to be in radians. So if you put it in degrees, do you think they'll have the answer there? Yes. So what they'll often do is they'll give you, if they give you the angle, they'll give it to you in degrees. You have to convert it to radians. Or you'll find the angle and then they'll ask for it in degrees because you have it in radians. So they make you convert throughout it. So here we have a pendulum 30 centimeters long. Swings through an arc of 45 centimeters. Through what angle does the pendulum swing? Yeah, you bet. So we're going to have theta equals, this is my A, this is my radius. Why is it my radius? Because if I draw the whole circle around, this is actually just the radius. So theta equals A over R. Centimeters cancel, that's why they have to be in the same units. And theta equals 1.5 rads. says to the nearest tenth. And then degrees to radians, pi on top. Radians to degrees, pi on bottom, already pop. So we're going to get 1.5 times 180 divided by pi. Remember, you should be trying these in your calculator because just because I can do them doesn't mean you can. So we always have to practice. 85 decimal what? 9. I'm good? Degrees. If I don't put the degree symbol, what is it? Radians. Yeah. Can you guys try this one? Right here. Okay. Calculate the arc length to the nearest tenth of a meter of a sector of circle with diameter 9.2. So what's my radius? 4. We divide by 2. Sector angle is 150 degrees, but we're going to multiply by pi over 180. So what do you get? Sorry, what's this in radians? 150 pi over 180, not rounded. That sounds like a whole bunch of decimals when we could just have it as the exact value, which would be much better. Yes. You always, unless specified for decimals or whatever, you always leave it in exact values because the moment you're rounding a decimal, you are. It's okay if you hold it in your answer, but how are you writing this down as a step for a written response? You let me know. ... No. That does not work. You can't go ... You have to actually write this down. So we have theta equals a over r, and we're solving for a. So I'm going to multiply our r up. So we have a equals r theta. So now we're going to show the work. A equals r, which is 4.6 meters, times 5 pi over 6. You guys need to learn how to show your work. When you type that in, what do you get to the nearest tenth? 12.0 meters. Pardon? You can't write out the whole decimal. No. That's called rounding. If the actual answer in your calculator stopped and terminated, you could write that. But yours is not. And these will never terminate because they have a pi in them. They have a non-repeating non-decimal attached to them every single time. Next page. So here's the coterminal angle definition. They have the same terminal arm. Principal angles are the smallest positive rotation angle. So if I ask for a principal angle and say you had gotten 410, then the smallest principal angle, so say it was 360 to 410, for a very good reason. This is 410 degrees, which is how many degrees then? From here to here? 50. So the principal angle would be 50. Because the principal angle is the smallest positive angle between 0 and 360. So how could we find that quickly? Because you guys know about coterminals already, we could just subtract 360 off of it, and it would get us 50. And 50 is between 0 and 360, so we'd have the principal angle. Yeah. You'd have to add 360 to find its coterminal angle that falls between 0 and 360. Yeah. And then this one you did last year too. Reference angles are the acute little angle between the terminal arm and the x-axis. I kind of crossed it out now. X-axis. Reference angles between the terminal arm and the x-axis. I always say it's the bow tie angles. If this was your terminal arm, it would be here. If this was your terminal arm, it would be here. If this was your terminal arm, the reference angle would be here. And if this was your terminal arm, the reference angle would be here. And if you connect them, they make a bow tie. Not an hourglass, which would be if you did with the Y's, which is not what it's supposed to. Oh. I think it's a what? I will just say it's because of your eye that you were completely wrong. Just hard to see it. Sketch the following rotational angle and give their reference angle and then 2 coterminal angles. So to sketch it first. So we're going to sketch 60. First thing we do is label. We start here, up to 60. Maybe a little more than 60. I may have overextended that arm a little bit. Sorry. What's my reference angle? So what can we say about angles in quadrant 1? This is quadrant 2. Yes. In quadrant 1, your angle is the reference angle because the angle from the x-axis to the terminal arm is the angle. That's there already. So my reference angle is 60 degrees because it's from the x-axis to the terminal arm. So all quadrant 1 angles from 0 to 360, obviously. The reference angle is that. Let's say I want to do coterminal. I'm going to do one positive, so it'd be 60 plus 360. Because if I add another whole 360 to it, it'll bring me back to there again, right? So 60 plus 360 is what? 420. And then 60 minus 360. If I want to go the other direction, it's going to be at what? Negative 300. Now, if I drew either of those angles, they're going to end up on the same terminal arm, right? You could, yes, you could keep going. So what they'll tell you, the reason how they'll narrow you down is they'll either give you a domain for the coterminal angle, so they'll say between 360 and 720, or they'll only give you A, B, C, D options on your test, and they'll only have one of them be the actual coterminal, right? So you have to figure it out. 5 pi over 3. So we have 0. 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. 360 is 2 pi. You have to label the outside in radians if the question is in radians. If you want to convert it to a degree so you actually know where the heck it is for first off, that's fine. But you have to draw it in radians. So radians to degrees, pi on bottom. What's that? Is it 300? And 300 is 60 away from 360, right? But you still have to label this in radians, 5 pi over 3. Now what's our reference angle? How far are we away from the x-axis? 60. And what's 60 in radians? 60 divided by 180. If my question is in radians, my answer has to be in radians. Pi over 3. 60s, 30s, and 45s are easy. 45 is pi over 4, because it starts with 4. And then 60s and 30s are the actual opposite. So 60 degrees is pi over 3, and 30 degrees is pi over 6. They're just over different numbers. So 30 is pi over 6, 60 is pi over 3. And you'll memorize them. Now, it's faster to do coterminal angles with radians by just actually keeping them by adding 2 pi and subtracting 2 pi, rather than converting it to degrees, adding 360, converting it back to radians. So, if I just take the original, which is 5 pi over 3, and do coterminals. And I add to it 2 pi. I want an exact value, so I'm going to leave the pi out of the mix. I'm just going to add 5/3 plus 2 into my calculator. You get what? And then if we do 5 pi over 3 minus 2 pi, what do we get? Which makes sense, because if I went this way to get me to that terminal arm, it would be negative pi over 3. It would be negative 60. I want you to do D and D. You're welcome. I don't know why I didn't put it. Is this negative 150 degrees? Oh, right, it's a 60-degree reference angle, not a 30. Based on the bottom, if it's a 3, it has a 60-degree reference angle. So we have 0, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. If it's in radians, you need to write radians. You can't write the degrees that you found. You can find the degrees to draw it, sure. If it's in radians, you need to write it in radians. What is my reference angle? How far away? The reference angle is 60, right? Or pi over 3. And then if I do my coterminals, I'm going to go negative 2 pi over 3 plus 2 pi. What do you get? So then it's going to be 4 pi over 3. Yes, because of the denominator. Yep. I didn't get where you were going at all with what you were saying. You're just making common denominator indirectly. And then 300. So our reference angle is always 60 because basically they've been 60 this whole time. So for now into life, reference angles are 60. No, that's just silly talk. These just happen to all be 60. And then my coterminal is going to be 300 minus, oops, 360. Wow, that really didn't look like one. Enjoy. Minus 60. And then 300 plus 360. So we're doing the first part of the homework. A while. It's chapter 4 and 5 before you do your test. Yeah. That's a C. These are mainly either convert or just sketch. And usually one's a degree, one's a radian.